Turn that one on and that. You're good, you're good. I think this is better than what was before, right?
Is this okay? Did everybody sit there with us?
Come on.
We'll put the full lights back on when you guys start working, don't worry.
Did you want to test the location before you still work?
If you're standing right over there, it should be just fine.
Video test. It was successful. Don't worry.
Trying a live stream.
It's here for data. Come on in. Grab some seats.
Data science. Who would have thought? Only our parents knew that was the future. Let's say, son, get into data.
It's Cape Canaveral. TIY Guest. Cape Canaveral.
TY guess? Lowercase?
Okay, bear with us. We are trying to live stream this. At least better than we did the last Python meetup. Hi! Hi everyone, this is Orlando Machine Learning and Data Science. This is our first meetup. Now, I'm Michael DuPont. I'm a big data machine learning engineer. I organize this meetup and co-organize Orlando Python. This is Casey Face. She's my co-organizer, and she's just getting a new job at Code School. She's going to be giving you a presentation about creating effective data visualizations today. I have a couple things to go through.
Do these ones for you.
Oh, so again, this is our first meeting. There is a previous group, Orlando Data Science, which kind of unfortunately no longer had meetups anymore. Sad, but here we are. Go ahead, next one. So we meet on. Click on it and then here it is.
Click on what?
Here.
Okay.
You should do that.
Okay.
Okay, so we meet 7 o'clock every second Wednesday of the month. We're starting in the Iron Yard. If we end up getting too much bigger, we might have to find another space. But for now, we greatly thank the Iron Yard for allowing us to be in here.
Iron Yard!
Next one. So, I want this to be different than other meetups. And I might as well specify this out while we're here. The first one, half of this meetup is going to be workshops like we're going to have today. We're going to choose a topic, we're going to dive in. We're only going to spend a short amount of time actually having a presentation or a talk, and most of the time it's going to be spent working in small groups, mentor-mentee style relationship. And by the end of the meeting, we'll have a show and tell portion where everyone can get up, show off what they did. We'll collect those and have them in Medium post so that everyone can have their work shown off at the end of each meetup. These are some topics that we have. The other half is going to be things like regular talks. We'll have people come in and talk about what they do or a particular project or technology that they're working on. These are ideas that we have for future talks and workshops. I believe we have someone lined up to do our studio next time. But if you're interested in any of these or anything that's not up here, please let me know. We have a wonderful audience. Go ahead next. And so you can find us on the ODEV Slack. If you're not on ODEVs, get on it immediately. It's a great resource. There's about 2,000 developers in Orlando. We have a data science channel. There's only 53 people in it, so it could definitely use some tender love. If you're not on Slack already, ask anyone that is on Slack. We can invite you using your email, and then you can invite more people. We're trying out YouTube streaming, so anyone who can't make it here, hi everyone. If you can't make it, you can watch during the presentation, and it's also saved later for anyone that wants to go back and review the information. And as I said, we're going to put a post up on Medium after each meetup. Give us about a week to do that, where we recap what we did and show off the projects that you guys worked on during the meetup. And I don't have a slide for this next part, but going forward, we're going to have some really fun things. We're getting a lot of help from Microsoft. We're going to have a ton of Azure credits that we can use, setting up servers so that we can do some fun Keras, neural nets, and machine learning. Some really fun things. But we are still looking for sponsors. It'd be kind of nice to have some food here. If your group is interested in sponsoring us, get in touch with me. And with that, I will turn it over to Casey Faced, who's going to be giving our intro talk for this presentation.
Thank you, Michael. All right, welcome, guys. So this first lecture thingy, we wanted to be kind of inclusive of everyone. So if you're coming in, you have extensive data experience, or you're still a little intimidated by Excel, we want you to find something in this. This is about communicating Okay, so the first thing you have to think about if you decide you want to visualize some data is what data can you use for a visualization? There are three big things when you're trying to decide if your data is ready for a visualization. The first one is clean. The second one is focused versus biased data. And the last one is univariate versus a multivariate set. Go ahead. So that first idea, clean data. Oh, by the way, guys, if you have any comments, questions, concerns, I'd love for this to be more of a discussion. So raise your hand, shout out at me, all that stuff. So good data, bad data. When you're visualizing, especially, this is true for any kind of analysis you're going to do as well, but especially for visualization, clean data is essential. You're not going to do this until you know where all of your null data is, you know what data you're missing, you know whether or not you're going to fill in some data, you're going to extrapolate it from the other points you have. So something like this, say I had these three categories, and I wanted to visualize all three of them at once. So I want to look at, looks like that's school versus completers, and then percent female and percent male. Well, there would be several categories, several school districts I would just have no data for. Whether or not that's relevant for my visualization, I have to decide. Maybe I'm just saying, okay, for all the data I have, this is the percentage completers. Or maybe I think, okay, that will throw some serious bias into my data set. So that's the first thing you have to think about, whether or not your data is ready. Next. Oh, yeah.
I have a question, like when you decide which data is right or wrong,
Mhm.
on what basis do you decide?
On what basis do you decide? So that is going to be highly specific to the situation you have. The reasons we could do visualization are to learn more about your data or to present findings. So this could be after the steps of cleaning, and now you want to say, okay, is this right for a regression analysis, or should I do a classification? The first step is you want to see, where does my data lie? And in that case, you don't want to do as much kind of exclusion, right? You want to see what all of your data says. If you are to the end of a research project and you know that you got some fuzzy answers, but you want to present the clearest picture of what you think your findings suggest, then you want to make sure that you only use the data that shows something, which actually falls right along with outliers. This goes kind of hand in hand. So who's felt this before? So when deciding when you're visualizing, you have a little bit more room, not so much, but a little bit more room than when you're analyzing your data to determine what's an outlier and what isn't. Right? So if you have gone over this data a million times and you know that the overall trend is supported, and you want to maybe not distract your users with that one outlier, then you need to make the call whether or not you're going to leave those outliers out. How many outliers are you going to leave out? Are you going to take just a quartile of your data, maybe the 90 percentile, and display that? So you have to decide what stays and what goes, essentially. And lastly, you have to know what your data is, what you're visualizing. So if you look at this isn't going to work because it's projecting, but if you pretend that these aren't here, you don't see these other two, and you're just looking at this first bar, you have a univariate distribution. Does anybody tell me why?
It's one variable.
Yes, it's only one variable. You're looking at just this dose, so you're pretending that these aren't there, and you're just looking at how the length affects that. If you're looking at multiple variables at once, you're looking at them together and looking for some sort of analysis. So if you're looking at this one to this one, and you ignored how the length compared, then you could say, okay, this one is shaped this way, and this one is shaped this way, and this one is shaped this way. But by putting them together, by having those multiple variants on the same graph, then you're actually saying something about all 3 points as a whole. So that would be that multi. Any questions on that? No? Okay. All right, so when digging into this, I wanted to make a really quick note of this. What you should visualize in depends on where it's going. So where your data is coming from and where it's going. If you want to present something on the web, maybe think about a JavaScript kind of D3 solution. If you're just working in Python, there are lots of cool tools in Python. If you aren't working in a programming language and you just want your data to come out, looking at something, there are plug and play kind of high-level options that you have. So whatever gets you, you have to weigh between the amount of control you want, whether you want everything to be exactly as you want, versus how quickly you want it and how cleanly you want it. So all kinds of options. All right. So as I mentioned before, visualization is communication. So this is a little bit of a different mindset as when you first sit down with a set of data. Is that now you have to think about not what the data is telling you, but what you want the data to tell other people. So let's go through some examples. A couple different data types you can have when you're communicating. So who knows what numerical data types are? This is a trick question. You all know.
Yeah.
So, yeah, it's numbers. It's the state of this numbers. Categorical? What's an example of categorical?
Pie charts.
Pie chart. That's a type of graph. Look at
I
what.
guess you could have surveys.
Gender, race, ethnicity.
Yeah, your actual data types would be something that's not like you can't say it's 1, 2, 3, 4. It's not any kind of relation. It's like apples, oranges. It's like balloons, puppies. Some of these are good for counts kind of thing. Time series would be an example of a time series. Something like the rate at which I speak over the length of this performance.
Weather.
Weather,
Yeah.
yep, weather could be a time
Mapping.
series, yep. So what are some of the issues in relaying information? How do you communicate the differences between these? What do you think?
So the time series might be a continuous data set, and the categorical would be discrete,
Yes.
and numerical depends like whether it's discrete or continuous.
Yeah.
Both.
Yes, excellent. So you have those discrete and continuous graphs. How would you communicate that to me?
Maybe different kinds of graphs.
Different kinds of graphs. Okay. So this is an example of a numerical and a time series graph. Let's pick this apart. Okay, so first of all, can we tell that it's a time series graph?
Yeah.
How?
One axis.
Yes, we have a clearly marked axis that indicates a time series. How do we know that it's a numerical? So the y-axis. This is a really clearly communicated graph. It has those very clearly marked axes that show a clear relationship. As you go farther into April, different things happen about those numbers, right? We don't know anything about those numbers. They're not marked. We don't know what they say. So this wouldn't be a complete graph, but it's a clear one. This is a very interesting kind of bar graph. Who's seen one of these before? Okay, cool. All right, so this is a subdivided bar graph. This is a really good way to compare data across a couple different metrics. So how many metrics are in here? How many different variables are in this data? Just shout out one. 16? There's 2?
Well, there's 6.
6?
There's two, eye color and hair color.
There are 2 different hair colors. Oh, sorry. Yeah, no, 4 different hair colors.
So there's these
Or-
hair color, there's these eye colors over here. These are our eye colors. These are our hair colors, actually.
I think people are confusing how many different variables there are as opposed to how many categories there are.
Yes.
So
So-
there are four different color types.
There's
Yes.
only 2 variables for the
Yeah,
bunch of
there's
categories.
two.
So we have the same categories across each bar. We have these different portions. I'm actually
Should be reversed. Should be hair color versus.
so what this graph is communicating to us is both proportion and counts. So we look at the proportion of the whole, and we're looking at the eye color versus the hair color. So the hair color would be percentage of black hair colors with blue eyes, the percentage of black hair color with green eyes, percentage of black hair color with brown eyes, and then black with blue eyes. So it's telling us information about the count per category, it's telling us information about the percentage per category, and it's looking at multiple different categories at once. So, what's up?
So this multivariate.
Yes, this is very multivariate.
So we only have one. What do you call that thing that goes up and down?
Axis?
No, it has like the first
Bar.
column bar, right. If we only have one bar, then that would be single variate, right?
No.
Still
No.
multivariate,
No.
you're just playing
Because within that
percentages
one
and
bar, we still have
what?
multiple different categories.
Oh, okay. So as long as there's many categories, no matter at what level, then it's multivariate.
Was this a clear way of communicating this information?
No, those accesses throw me off.
No. That's why this is so important. This is really tricky. When you have multiple categorical values that you want to communicate, and you only have those counts, those percentages to compare, when you have a count, you're looking at either a bar graph or a histogram, right? So how do you translate that to 5 different categories in relation to each other? That's where it really gets tricky. All right, so we were picking apart, how did we know these different ways? How did we know the graph was trying to tell us something? It's on the slide.
Visual coding.
Yes, it was encoding information in lots and lots of different ways. That one maybe a little bit too many ways. So you could use anything you could draw. And actually, if you use interactive technologies, anything you can animate. So I have some of the most standard ones up here. Color, hue, saturation. Texture would be if something looks like it's, different texture. Shape, length, thickness, ankle, position, size. What are some other ones you could use to encode information? Think about.
Velocity.
That would you be communicating something?
Pound.
Well, speed.
If you had like sort of like a changing bar graph to show racers in a race.
Yes, so
the
if you're-
distance as time progresses.
That would be
someone
really cool.
accelerating, someone decelerating.
Yeah, so if you had an animated graph, something that wasn't a static image, you could have some speed of change be an encoding. You could have the rate of speed of a change be an encoding. You could have time be an encoding. What else?
How about depth of field?
Depth of field, that's a great one. How do you communicate that usually?
If it's a 3-dimensional,
Mhm.
like
Normally,
It's-
in a
it's
2-dimensional.
varied.
Yeah. What else?
Brightness.
odor.
I don't think we're quite yet.
Wow.
Well, if you use scratch and sniff stickers and be like, okay, this one gets 5 oranges and this one only gets 2. I can see that. But yeah, you're looking for small things to pin to, reliably pin to meaning. Now, you can't just use these all willy-nilly. And why not? When you're communicating, you have to think about the type of data you're communicating, right? Numerical can be an exact value, right? Can categorical be an exact value? So I know that I have exactly 9.6 puppies, but how do I communicate puppies? Can I say I have exactly puppies?
You say I have puppies.
I have puppies, right? So something like color or a shape, something that's can't measure to a graph, would be better for something that's just categorical, that you're only going to compare kind of apples to oranges. When you're using numerical data, you want to use something that's easier to actually measure and see. So if you know that the mean of your graph is somewhere around a certain line, you want to make sure that's really clear, right? So your clearest ways, some of the basic ones, clearest, and this was ranked in I'll link I think I have the paper linked. Yes, I do. There was an actual study about how accurate people were while reading graphs, how accurate they were able to guess the true values that were encoded in the graph. Yeah, it was really cool. Everybody should go read it after this. But some of the most accurate ones were points, angles, position, and size. Over time series, lines were somewhat specific if they were in series. So if you use a line to represent a bunch of non-continuous data, that can be really, misleading, right? So time series are still those lines and some movement. If you have an element that's repeating, you can show that it's that same element over a course of something. And then when you're looking at those categorials, they don't need to be as exact. So that's where you want to use different tones, different colors, maybe less obvious changes, but changes that are perceptible. So just some things to think about while you're creating yours. Now, here are some examples. And hopefully these are both better and worse than the examples we've seen before. First up, here are some good visualizations. What makes these good visualizations? Any ideas?
Got the map, you've got like points of references of place names that you know.
Yes, so both of these are very precise. You can look at the graph bar and say, okay, how many have exactly, you can't see this number, but it's 50,000. How many have 50,000 dispatches? You can go across and have this one does, and this hour of the day does, and these hours of the day does. You can match it to exact data. And the same thing for in these bars, you can match these. If you went in and drew that many tick lines, you could get an exact value.
It's really hard though. In the middle of the graph, I can't tell the difference between the sizes of the greens.
It's his graph, take it up with him.
If you want exact values, you don't really want a graph, you want a table. If you want to see trends, overall comparisons, graphs work better. They don't work real well if you actually find yourself tracing across and trying to figure out what number it is. Tufts got a whole book about that. It's called the Visual Display of Quantitative Information.
Right.
Yeah, the
Great
tricky,
book, by the way.
the tricky thing, what I've seen is people on both sides, either they get too artistic, too kind of flouncy with their visualizations, or they might as well have just put a list of data points on the sheet. It's finding that balance between them.
If you find yourself dropping a 5-point mesh grid over it, you've gone too far.
That's a good point. Thanks, guys. Same thing with this. This is a good visualization. Welcome. Here for data? Awesome. Come on in.
Free data. Free data.
Heat maps like this can be really cool and really, same thing. You can look up, okay, in this place, it has this level of housing price. Now, what's this one missing versus that one?
Legend.
Yes, always include your legends. Never exclude your legends. We actually don't know anything about what these colors mean, which makes it much less readable.
It's a heat map.
It is a heat map. You can infer that warmer colors means higher, but you don't know the ranges, right? You don't know if that's actually what they intended. So never forget your legends. Important lesson. All right. Now, to speak more candidly about bad graphs. Thanks, guys. All right, so what's wrong with this one?
It's chart.
I'll start you off. 60% of what people? Who? And is it any kind of easy to compare these values? I don't even know that those values compare.
60.4% of that 60% of iPhone or mobile phone wanted people want iPhones. Or
I think the bottom bar is too long. So Nokia bar and the BlackBerry bars are longer than they should be.
But
Yep.
that's definitely not the scale.
Yeah. It's not to scale. There's no other axis. Is that 60% of the 60%? Is that 60% of the whole? So are like more people want an iPhone than people that want a mobile phone for Christmas? Is that?
Yes, if you-
So there's a lot wrong with that one.
Too many typefaces.
What else?
Yeah, I can't read that.
Font.
No.
Too artistic.
Yeah, it's too over here trying to be art rather than informative. What about
Why are
this
there
one?
red stripes on the bars? They're not-
It's
That's
at
just people to
Christmas. It's
decorate.
supposed to be a candy cane, which is why I said let's speak candidly about bad graphs.
But on some of the bars, the distances between the red bars are different on the.
They probably hand painted it. Yep.
They really should.
Maybe
be
they're
ambitious.
encoding that there's like a rate. They really want that BlackBerry more than the other ones want
Let's
them.
go. Oh, hold on.
Anything else? I like that one. That one was fun.
Is that like COVID?
So this one is actually it's a real kind of graph. It's called the Swiss cheese graph. Never use it, please. No one ever here ever use it. It's intentionally they've taken out bits of the data at certain points to reflect that they're the same data at that point. Which is interesting because there's 2 bars. What else? So yeah. What's wrong with this one? Why is this less than readable? It has a legend. It has an axis.
I think it's misleading just because, first of all, the second bar, it's on such a small scale that there's no reference, and because of the Swiss cheese effect they're trying to go for, it's completely like. You know,
If
it's
you
just,
want to compare 2 numbers, you should just print 2 numbers side by side.
What does the second bar supposed to mean? Are you supposed to read it?
That's an excellent question. How are we supposed to read this?
for 2 bars, I would just put 2 numbers in the table.
Yeah.
It's really hard to tell to whether or not it's really a bar or a scatter plot. It's dense.
Another thing I want to point out here, this, in comparison, it's bigger than the whole graph. Their label down here is bigger. It's about, so readability's sake, yes, that would have been really hard to read if it was smaller, but you could have found a better, maybe a more clear name for that, maybe another way of encoding that. Also, if they're really 2 different categories of things, why are they both the same color? Anything else? No. They're terrible. Let's move on. So there is a site out there. If you ever feel like a laugh, it's called WTF Visualizations.
It's on
These
Tumblr.
are real graphs that real people have really made with their actual time. It's so on this hand.
Can't read that.
No. It's all the same color. So they chose to encode it in a color. It's all the same color. And there's really no
Oh, that's
distinct.
2-dimensional?
Yeah.
Oh,
Yeah,
God,
so if you're
no,
looking at
that's not
these, oh yeah, then there's the little bars right there. It looks like kind of like a skyscraper blue line. So maybe if there was like an overall trend they were trying to communicate, maybe an area bar would have been better, or maybe anything.
So it's
A line, yeah.
the data there is actually quite useful because you've got a lot of it, but it's just how it's actually presented.
That's true.
Because you can get some quite good moving averages on that data, for example, so it actually be quite it's actually quite accurate. Yeah.
Absolutely.
If they knew what they were doing, they would have made that plot.
Yes, if they knew what they were doing, they would have made a better plot. I agree. This is a good example of when you have your finalized data, but then you think about what kinds of transformations you want to apply. So do you want to flatten it to an average across what? Across maybe this way, or maybe you want to flatten it into averages this way into a count. You want to think about what trend your data is actually telling you. So how are you looking at? It looks like this is actually a time series. So why are they even using a bar graph for a time series? That's something they want.
Line would work.
Yeah, line, ribbon. Sometimes area plots. If you have multiple different categories of things to show over a certain time period, you can show that area as a breakdown like those bars. But that ain't it. And over here, it is pretty.
Whose flag is
It's the flag of Nintendo.
that?
So the biggest problem with this is that it is countable. It could tell you an exact percentage, but you'd have to sit there and be like 1, 2, 3, 4, 5, 6, 7. And then I guess they do have their axes down here, so they get that. But seconds to sell a Nintendo NS Classic on eBay. This doesn't tell you much about what the sample size was or how many sold per day.
So you use a pie chart for that, right?
No.
No?
Friends don't let friends use pie charts unless in extreme
So you're
situations.
supposed to number the pie chart, right?
No.
No. It's discreet though.
So the problem with pie charts, I'm glad someone brought this up. So pie charts, guys.
Some people love pie charts. Like
People
math
love them
deal.
because proportionately it's easy to say, oh, that one's bigger than the other. It's really only good for comparing really hazy counts of categories. It doesn't really tell you exact percentages. It's hard to estimate. In that study I mentioned, pie charts ranked one of the lowest as people were able to accurately read. So for accurately communicating data, it's use something else.
What would you
Even
do?
if you put the percentages on each like slice.
Well, then you're just giving them data. And why isn't it in a table? Then it's just a table with a pretty background.
I don't know if people love pie charts.
People like them, but
If there's like less number of things to compare, like 3 or 4, maybe the area proportion might be a better way. I mean, it might be better represented in a pie chart. Yeah, if it goes bigger, I agree. It's not.
yeah,
Smaller.
maybe. My personal opinion is that if you can represent it in a pie graph, there is a much more beautiful version of it somewhere else in some other kind of graph. That's my belief. Okay. All right. Now, hopefully you feel prepared to be connoisseurs of data visualizations. For those of you who don't watch Star Trek, I'm sorry, I had to. So yeah, let's get this. Oh, here are the resources that I listed. We can set these out on the. They're a really cool kind of nitty-gritty look at how different types of encodings have been performed in different types of settings for reading. So, yeah, that's an intro to visualization. All right, now it's time for the fun stuff.
Indeed. So, that was exactly 30 minutes. Whew. Yeah. So, workshop time. In the presentation, which I've linked to in the meetup description and the stream for everyone still there, and in the meetup description itself, I have links to 3 different data sets. If you've already chosen which one that you want to do the workshop with, that's great. If not, find someone who either wants to work with the data or find someone who is using a tool that you want to learn how to use. And there's obviously three very different sizes on there. The Florida grad rates was provided to us by someone at OpenCode 2 months ago. With the smallest data sets can be one of the easiest to work with. There's Orlando tree orders, which and OPD dispatches, which are from Code for Orlando. OPD dispatches is obviously the largest data set. It's 150 megabytes. So if you haven't downloaded it already, come to me. I have it on a zip drive, and we'll give it to you. Don't download it over the internet. So for this workshop, we're still testing this out. I would like to raise your hands or people that are comfortable making data visualizations and have brought tools that they are comfortable using. Make yourselves known so that anyone that isn't quite as comfortable or wants to learn a new tool, either one of the ones we listed before or one that we've never heard of before, go ahead and get into those groups. You can use whatever tools you want, create some visualizations, and in an hour or so, we'll come back and do a show and tell of the visualizations that everyone made. So, break. Anyone? Go ahead. Anyone that is comfortable leading a small group with the tools, go ahead and make yourselves known to everyone. And here, we're going to stop the stream.
Thank you. Here, let's enjoy this.